Hello. Now, the other day I was walking around Lidl buying bananas and milk and all the stuff I usually buy there. And I noticed this in the office section. It's a multimeter. And normally I just point and laugh and keep on walking, but something caught my eye, and it's this here. This meter's got a category 3, 300 volt safety rating. And this rating is certified by TÜV and by the German government. And this is on the packet, it's stamped on them, printed on the meter and everything else. And this is on sale to the general public in Lidl, so you know there's no way they can be putting a fake rating on this meter. So the question is, can we get category 3, 300 volts, which means it's safe for working on mains electricity, Cat 3, 300 volt meter for €12.99. Well, let's get it opened up and find out. So, in the packet we get the meter itself, which is red plastic. This isn't kind of a rubber shoe, anything like that. It's just a hard red plastic meter. Passes the twist test, no strange noises. Selector seems quite clicky. Little on-off switch. Seems okay. We also get the battery. We get a screwdriver to put the battery in with. Never seen that before. And we get the leads, of course. So let's get it put together and put it through its paces. And let's see what we got. Screw. Okay, that slides up. It's got two little arrows marked there. So standard 9 volt battery clip. Together, you point out metal insert there to hold the screw, always good to see. And we're ready to go. Peel off the screen thingy. Turn it on. Here we go. Seems to work. And let's check out the leads. Yep, PVC smell. Definitely PVC leads, I would say. So what you expect for this price. And take out the little covers. Does anybody know what these are for? Do they fit in there? No. You always get these in these leads. What for? I don't know. Yep, definitely PVC. You can see they act like the springs. And any markings on them? Yep, it says again here, Cat 3, 300 volts. So they match the meter. And they've got the safety covers on them, of course. And they don't seem to be removable. That's quite... Well, we'll look at that in a minute. But anyway, yeah, I mean, I guess if you're selling a meter to the general public, you don't want these to come off. You want this to be as safe as possible when they're poking them in the main sockets. But that's probably quite annoying if you're an electronics engineer. But still, got strain relief on the ends, which is okay. Let's get them connected up. Okay, that's a bit weird. They go in almost to the end and then you gotta press really hard and they click into place. Never seen that before on a meter. Okay, turn it on. Let's do a continuity test. Seems to work. Okay, let's just do a quick comparison. These leads belong to this meter, and they've also got these covered probe tips, just like these, that come with the LIDL multimeter. The difference is that these covers come off, which is very handy when you're working with things like resistors. You want to measure a resistor, you can put the lead of the resistor onto the probe tip and hold it there while you take a measurement. Stuff like that. And the probes even have a little groove there, little notch which holds the thing in place. If you slide it up, you'll see there it kind of clicks into place, and now it doesn't move. Makes a good contact. Take your measurement. But with the LIDL meter, these things aren't, I'm pretty sure they aren't removable. They seem to have like a gap around there that I can get my fingernail in, but nah, they ain't coming off. So that's going to be pretty annoying if you're going to be using this with Arduinos and whatever. I mean, it's good for mains work, it's a lot safer because you can't, you can't put your finger like this and then poke it into the distribution panel. Okay, so this is much safer, which I guess is what they're aiming at. I mean, they're selling this meter to the general public, so they want safety, safety, safety. So good for that, bad for Arduino work. And the screen's very nice, nice big digits, plenty of contrast from all angles, no problems there. And hidden in the box there's quite a chunky manual, and it's in 1, 2, 3, 4, 5 different languages. Let's find an English, near the end. So here's the specs. You got 0.5% on the DC range, on the low voltage range, up to 1%, both plus or minus 5 counts. AC volts 1%, current 1%, up to 2% on the 10 amp range. Resistance again 1%, up to 1.2%. Does measure up to 20 mega ohms, that's quite good. And a square wave output, 10k ohm output impedance. So we've got a new multimeter, and obviously the first thing to do is to poke the lead into a main socket and see if we get 230. That's 230 volts here in Spain. Now there's 2 rules to doing this safely. Rule 1, put the leads in the correct holes. And normally you put the black lead in the hole marked COM, and the red lead in the hole with a V printed above it here, V. Okay, because we're measuring volts. Rule 2, put the selector in the position for reading AC volts. And if you look at the meter, there's 2 ranges with a V on them. This is DC volts, this has a line and 3 dots underneath it. But we want AC volts, which is a V with kind of a wiggle underneath it, because the mains voltage it's a sine wave. So this is supposed to be the sine wave of mains voltage. So we turn the selector to this range, this group of ranges, and what we want is the highest number. In this case 300. Okay, and then we're ready to measure this. Double check it. Leads in the correct hole, selectors on the right range. Switch the meter on. And put the probes in. Okay, I've just edited out a bit of video because it took me a while to figure it out. This socket actually has a safety feature. I don't know if you can see it on the camera, but there's like a little brown piece of plastic in there, and if you try and poke something in, you can't. And I finally figured out that what you need to do is you need to push both sides in both holes at exactly the same time, so as if you're putting a plug in, and only when you do that does it move out of the way. So a clever little safety feature on this extension lead. Anyway, we've got the probes in, and the meter is on 300 volts AC. So let's take a reading. And bit of a dodgy contact. So I can get 230 volts. There we go, 230. But if I let go the leads, yeah, okay, it is. Well, no, 230 volts. And I'm guessing it's just a bit of a bad contact because and let me just get the mains plug to look at. Got one here. Switch that off. I'm guessing that's just because these probes are quite small compared to the prongs on a mains plug. So when you put it in, you've got to jiggle it about to touch the sides where the contacts are. But as we saw, get those in there, switch it on. 230 volts, no drama. It seems to work. And let's do some accuracy tests. I've got my little reference box here, and let's see what we've got. Let's start with the ohms range. So same procedure as before. You want the red lead to be on the connector with the ohms symbol on it, because this is what we're going to measure, ohms. And the selector switch in a position suitable for what we're going to measure. So we're going to measure up to 10k ohms, so we can put it in the 20k range. Okay, so this should say 10. And we see 9.98, that's pretty accurate. Let's go down the range, this should say 1. 0.996, that's pretty accurate again. What's that? That's 0.5%, that should be, that's about right for this meter. We're going to measure volts, so let's go to the DC volts range. And the cable, the lead is already in the position for measuring volts. Don't need to change anything there. Let's measure 5 volts. So 5.01. It says I had the leads the wrong way around. It says minus because I got the lead swapped. Okay. Swap the leads around the correct way. 5.01. So it's 0.01 out. That's pretty accurate. And then 2.048 volts. 2.05. Again, plenty accurate enough. Switch to the milliamps range. So the lead is in the correct hole for measuring milliamps. It says here MA, milliamps. And we want to be over here somewhere. Let's measure 10 milliamps. So 10.02, that's pretty accurate. Finally, up to 100 microamps. This should say 100. And it says 100.1, that's pretty good. Okay, so basic accuracy tests, thumbs up. And continuity test. Now the continuity test is this symbol here, kind of the dot with the 3 lines next to it. That's in the ohms section of the dial. So the red lead needs to be in the hole with the ohms symbol next to it. Okay. And what it does is when we touch these together, it buzzes. Not the loudest buzzer I've ever heard, but it'll do. As for speed, that's not too bad. I mean, it's kind of hard to do the speed test with these shrouded points, leads. So I'll do what I can. Yeah, medium speed. I'll give it. No, I mean you definitely can miss the contact, but it's not the slowest I've ever seen. Now let's do a diode test, and the diode is this little diode shaped symbol. It's on the same position as the continuity test. So both things are on the same setting. And let's see if it can light up this white LED. And nope, it appears it can't. So it can't light up a white LED, but that's kind of okay because it's only a diode tester. It doesn't say anywhere on here LED tester. I mean, LED is a type of diode, but a white LED is quite difficult to light up. But anyway, let's find out what it can actually do. Let's start with an actual diode. Let's see if we can test this and get a reading. So to test a diode, you put it with the band on the diode onto the black probe. You test it in this direction. You should see something like about half a volt. Okay, so 509, that must be millivolts. So half a volt. And if you flip it around, you should see 0 if the diode's working. Okay, so in this direction, half a volt, and in this direction, nothing. Okay, so as a diode tester, it works. Now let's test some LEDs. I've got 4 LEDs here, white, blue, green and red. And this is in order, the most difficult to the easiest. This needs more volts to light up and this needs less. So let's find out if it can light up any of these LEDs. I'll start with the most difficult, which is the white one. Well, it should be the same as this. I don't expect this to light up because these are both white LEDs. This one's a lot bigger, but it's the same principle. Okay, so I'm not seeing anything there. No surprise. So, can it light up any of these coloured LEDs? Let's start with the blue one. I'll get it the right way around. So, blue. I'm not seeing anything. So, fail on blue. Green. Yep, we've got a voltage there. So you can see on the meter it's putting 1.8 volts onto this LED and it's lighting up. Yeah. Green LED. Green LED passed. And red should work. If the green one works, then the red shouldn't be any problem. So there we go, red LED. And that's lighting up at 1.69 volts. Okay, so diode test. Diode test works, and you can test red LEDs and green LEDs. Any more than that, not enough volts. Anyway, enough talk. Now's the thing you really want to see, is the insides of this meter. Time to take it apart. So let's start with the battery cover. Take the battery out. So what we're looking for on the inside is, I mean, given the safety rating of this meter, we need to see some proper ceramic fuses and a few safety devices. PTCs, protection resistors, clamps, that kind of thing. So, what have we got? Let's see, moment of truth. If I can get it apart. Seems to have some kind of clips. Here we go. And here she is. Okay, that's a little bit less than I was expecting, given the Cat 3 rating. Okay, it's only Cat 3 300 volts, which isn't a very high voltage, but I was expecting a little bit more than that. We've got 2 fuses, ceramic. We'll check out the rating in a minute. 1 PTC here, a couple of two transistors as a clamp, resistor chain for the input protection, but very small surface mount resistors, not kind of the MELF resistors you would usually get in a meter, and that's about it. So looking at the spacings, this is the it's quite useful. It's actually marked on the board what each socket is. I don't have to flip it over to find out which one it is. The 10 amp socket, so electricity comes in here, goes up there through the fuse, back down here, so plenty of gap around this area. Just spacing in case of a high voltage situation. No, sparks can't jump across from here to here, for example, because there's quite a big gap. So down there, the other fuse, you can see the track comes in here from this connector, goes to the fuse and across to these resistors here and these here, 2 chains. One will be for the input, one for the output voltages. Just nothing really, exciting about it. I'll give you a close-up so you can play along at home. I expected a little bit more. I would expect at least, a couple of PTCs on a meter with this safety rating. But, it's been certified by the German government, independently tested, so it must do the job. One other thing I can see here is the battery connector has got strain relief. They've put the leads through a hole in the board and done a little loop like that so I can pull on this lead. I'm not stressing the solder connections. And your buzzer, your chip, what else can I say? There's not much inside. Okay, I'm just going to pop these fuses out. I can. There's one good feature. As you can see this, the fuses have, just maybe see it better on this one, there's a little tab here on the side to stop them sliding out in place. So if I push it there, I can't push the fuse out because on this side there's a little tab holding it in, and that's good against vibrations, because if you bash this meter around a bit, the fuse can actually slide out of the holder, causing problems. But this one's got little metal tabs to prevent that. Okay, so let me just pull these out. I'm trying not to get them mixed up. This is the low current fuse, and this is the 10 amp fuse. So according to the PCB, it should say 10 amp 300 volts on the fuse. So the 2 fuses in this meter are, if I can get this to focus, which I don't know if it will. It's focusing more on the PCB than on the fuse. Anyway, 250 milliamps, 300 volts. So 300 volt fuse. And the other one is, yeah, it's not focusing, is it? But it says 10 amps, 300 volts. Come out, focus. Focus, focus. 10 amps. I don't think it's gonna, but anyway, 10 amps, 300 volts. So 300 volt fuses, correct fuses for this safety rating. Let's pop them back in. So, do we believe that this is a Cat 3 300 volt meter? Well, the fuses are correct. It's a bit wimpy, the input protection, that's what I'll say. It's only got one PTC and some little surface mount resistors instead of the big MELF resistors you'd expect in a meter like this. But it's been certified. It's on sale in a place that they wouldn't dare sell a meter with a fake rating printed on the front. The German government believes them, so I'm going to have to say yes. Cat 3, 300 volts. Now, we've mentioned safety several times in this video. So what's that all about? Why do we need a safe multimeter? Well, the safety components inside here are there for when we do things wrong. Okay? When we're measuring mains electricity, for example, If the leads are in the right holes, if the selector's on the 300 volts range, then we expect to be able to measure this safely. Okay, that's not surprising. The safety components are there for when we've got, for example, the selector in the wrong position or the lead is in the wrong hole. Okay, we all make mistakes, we all mess up sometimes. It happens. So we need to know what happens in this kind of situation. So imagine we were measuring continuity, for example. We're there, it's buzzing away. Okay, we put the meter down. We pick the meter up again, forget to move the switch. Okay, and then we stick the probes into a main socket. So what will happen? Will it make a very, very, very loud buzz followed by a fire? Or will it just kind of do nothing at all? Now, hopefully it'll do nothing at all. But let's do some tests and find out exactly what happens. So here we are. We've got 230 volts going through the meter. At the moment it's in the correct position. And what I'm going to do is I'm going to move through the different ranges and see what happens. Okay, I'm going to switch it off for each change just in case. So I'm going to start by stepping down through the AC volts section, and we don't expect any kind of big drama there. That's what it's supposed to measure. So I'll put it down there, switch it on, and it says overload, which is correct. Too many volts for this range. This is the 20 volt range. Again, overload. All good. And to the 2 volts AC. And overload again. And if we move back up to the 300 volt range, switch it on, 230 volts, 231 today. So that seems to be perfectly okay. And now let's start testing the DC volts range. This might do a little bit more weird things because it's not expecting an AC signal, a varying signal. It's expecting a steady signal. So we might get some strange readings on the screen. Anyway, let's see what happens. So it's on 300 volts DC. Switch it on. Nothing at all. But no drama, which is a good thing. 200 volts DC. Kind of a bit of a wibbly signal. Okay. 20 volts. Again, some kind of wobbling. 2 volts. Finally 200 millivolts. And the screen went blank. Is that a good thing or a bad thing? Let me just reset the meter. Let's come up again. Okay, so when I switch there, it looks like the meter has kind of disabled itself. And it seems to come back up again. Okay, so what I'm going to do is I'm going to test it to make sure it still works. And for that, I'm going to need my little voltage tester. So let's measure 5 volts DC. It says 5.01, that's still working just fine. 2.05, yep, so DC voltage still seems to work. Let me just go up to a different range. So 5 volts, about 4.9, good enough. On the 200 volts range, yeah, it seems fine. And the more difficult range for the meter is the ohms range. And this is more difficult because when you're measuring resistors and things, the meter has to actually output a voltage. When you're measuring volts, it's an input. When you're measuring ohms, it's an output. It's a little bit more difficult to protect. But let's see how well this meter does. So again, we've got 230 volts going in. And I'm going to move the selector through all the ranges, just like we did before. So we're starting on the highest range. And the screen went blank again. Looks like the meter kind of shuts itself down to protect itself maybe. So I'm going to reset it between each range and go down through the ranges. So all the ranges have done basically the same thing. When I switch the power on, they shut down. I have to reset the meter. And again, we'll do a quick test to make sure it still works after all that. So I'm going to measure my reference resistances, resistors here. Let's start with a 10k resistor. This should say 10 on the screen. 9.998, that's fine. Go down a range, 1k resistor. So we're looking for 1 on screen. 0.997, so still works perfectly. Next up, the continuity buzzer. Will it make a very, very loud beep? What will happen? Nope, nothing. Screen went blank just like before. Let's just reset the meter, see if it still works. Yep, no problem. And we've got one more range to go, which is the square wave output range. Just switch it around to there and give it a blast. Screen went off again. The meter appears to be working. Let's have a look at the square wave, see if it's still there. So, according to the manual, this puts out a 1 kHz square wave and approximately 3 volts peak to peak. So here we have it, 999 Hz square wave, 2.8 volts peak to peak. Perfect. Now, if you've been paying attention, you'll have noticed that we didn't test any of the amps ranges. And the reason for this is, if we overload one of the amps ranges, we blow one of the fuses inside this meter. And then we have to replace that fuse, and how do we know the new fuse is any good? We have to blow it again, and we end up in kind of an infinite loop of replacing fuses. And it doesn't really tell us anything about the safety of the meter, it only tells us about the safety of the individual fuse. So in these ranges, all we can do is trust that the rating printed on the fuses is correct. And as we saw in the teardown, they are 300 volt rated fuses, and that's the correct rating for this meter. So we'll just have to trust them. So what can we conclude about this meter? Well, it's a very basic manual ranging multimeter, but it has a full certified safety rating. We went round to test this, we went round all the ranges, plugged it into AC mains, and nothing bad happened. It kept on working perfectly. And this is something we could not do with one of these freebie giveaway meters. If you do the same test as one of these meters, do it outside is my advice, because it will explode or it will catch fire. Bad things will happen. Don't do it. It's quite well made, there's no creaks or rattles, it's got a good display. The only thing I would complain about really is the leads, which are very stiff PVC. I expect we'd use these wood straighten out, but if it was me, I would replace these with something a bit better. They're like a standard fit, so that shouldn't be any problem. And apart from that, really, no complaints. This meter's going to get a big thumbs up. Plus you get a free screwdriver. Check this out, German engineered Phillips screwdriver. Is that real ABS plastic? Could be. Nice.